All right, section 5.4, graphing square root functions. So this is, we're going to talk about graphing a new family of functions. And there's several families of functions, maybe a dozen or so. And these are functions that have square roots in them, but specifically square roots of the variable x in some form, okay? So if a function contains the square root of a variable, it's called a square root function. This is a type of radical function. Okay, so there's lots of different types of radicals: cubed root, square root, fourth root. Any kind of root is a radical function. Okay, here are some key things about this family of functions, and specifically about the parent function, which, remember, the parent function of a family of functions is the simplest form, the simplest version of that function. Okay, so if we look at the simplest version of the function, which is, I know it's a little bit hard to see on the camera, but the notes should be in front of you, the square root of x. All right, you see this is the graph of the square root of x. Over here, you see it starts there at 0, 0, and it goes off to the right. Okay, this is also one of the first places, probably not the first, but one of the first places where we actually have to think about the domain. In almost all the other functions, the domain was all real numbers. You almost really didn't have to think about it, although try to explain it each time. It consistently was all real numbers. With square root functions, that's not the case. All right, you can see domain is all of the inputs which have outputs. In other words, all of the x values that generate y values. In other words, all of the x values covered by the graph. All right. And you can see that this graph does not cover all of the x-axis. So its domain cannot be all real numbers. So in this case, in this specific version of the function, the domain is x greater than or equal to 0. And you can see that there's two different ways that you can write that. You can use inequality notation, which is x greater than or equal to 0. The book uses what's called set builder notation, where they put this little x in the vertical bar next to it. But really all I need to see is just that, x greater than or equal to 0. You can also use interval notation, which we haven't really talked about. So I would stick to inequality notation. The range here, all y values covered by the graph, excuse me. Also y greater than or equal to 0 because it only covers the positive y values of the graph, and 0. And you can see the intercepts there is 0, 0. There's no symmetry. It's not defined when x is less than 0. You can see there's no graph over here because you can't take the square root of a negative number in the real number system. And there's a minimum at 0, 0. Okay, so there's always going to be a min or a max with the square root function, right? And yes, the last thing is the domain of a square root function is limited to values for which the square root function is defined. Okay, all right, so let's look at this function here. Here, this is square root of x plus 4, and you can see it's only defined starting at -4, and that's because if you plug in numbers like -5, for example, you'll get the square root of -1, which is impossible in the real number system. All right, so the domain of this is going to start here at -4 and go forever to the right, so it's everything greater than or equal to -4. For the range, we're looking at all the y values that are covered by the graph, and you can see there's no graph down here. The graph picks up at 0, and so the range is y greater than or equal to 0. Right? So there's the domain and range for that function. Let's talk about transforming square root functions. All right, so every square root function can be written generally in this way. All right, in this, a represents the stretch, either horizontal or vertically, of the function. H represents the horizontal shift of the function. And k represents the vertical shift. So h is for horizontal, and k is the vertical shift. All right, and so you can get an idea of what these graphs are going to look like lots of times just by understanding how a, h, and k operate. So let's look at a couple problems like that. Move my microphone out of the way here. Sorry about that. All right, so let's look at an example here. So graph the function and state the domain and range. And so we are going to take a look at the graph. I put it in Desmos already, so let's go check that out. Should be right here. Okay, so you can see the graph in purple. we are just going to, probably the easiest thing to do is to turn this into a table so you can plot some points. Okay, you can see it doesn't pick up until you get past 2, or starting at 2, and then you can see you can get a few other points here. Okay, so let's plot some of those points. I'll do it while you're looking at the graph. So the first point is 2, 5, so that's here. 3, 6, and then we've got 6, 7, so 6, and then up to 7. And then you can just sketch that graph through. I've found that when I'm graphing these, I usually need about 3 points to get a decent picture of the graph. Okay. Another thing for this assignment, I did include in the packet graph paper that corresponds to each problem. So hopefully you will find that helpful for doing the assignment. Now we want the domain and range. The domain, all x values covered by the graph. So you can see that this graph starts here at x equals 2 and goes forever to the right. So it goes to the right at past 2, or rather starting at 2. So it's x greater than or equal to 2. And then the range is going to be all the y values covered by the graph. So we can see the graph starts here at y equals 5 and goes up from there, goes up forever. So all of these y values up here are covered by the graph. So we'd write that y is greater than or equal to 5. And that's it for the domain and range on that one. Let's do another one of these, a little bit more complicated. You should try this one and see how it goes. Okay, so here's the graph. You can see it's lower here on the x or on the y-axis. I'm going to turn this into a table again just so I can get some points. It starts at -3 actually, so we want to put in -3 here. So I got -3, -1. So -1, 2, 3, -1. By the way, I could have gotten that from the h and k. So right here, if I don't know why it's dragging the screen. If we have x plus 3 under the root, that means h is -3. That means that it was moved to the left 3 units. And if it's -1 on the y, it's moved down 1 unit. Okay, so we could get that from that. And then the negative out in front means it's going to be flipped, so it's got to be pointing down. And then the 2 means it's going to be stretched vertically by a factor of 2. So anyway, but we can get the table here. So we got -3, -1, -2, -3, -1, 2, -1, 2, 3. And then we'll see if there's one more point. Yeah, 1, -5, 1, -1, 2, 3, 4, 5. And you can get a pretty good picture of what this graph is going to look like starting here. All right, and then we need the domain and range. So the domain, all x values covered by the graph. You can see the graph starts here at -3, goes forever to the right. So it's x greater than or equal to -3. And the range is all the y values covered by the graph. You can see it starts here at -1 and goes down forever. So that's y less than or equal to -1. Okay. Last problem, number 4 here. Write the square root function that is represented by the graph. So we said in this one, and also when we defined the transformations, we said, look, based on h and k, you can figure out where this point, the maximum or the minimum, is located. So to work back from the graph, we're going to figure out what h and k are. In other words, we want to know what is the horizontal shift and what is the vertical shift. We won't give you one where a is anything other than 1. That kind of can get confusing, and it's a little bit hard to figure out from the graph. It's a little bit beyond what we're going to do in this class. But we can definitely figure out the horizontal and the vertical shift. So you can see that this has been moved to the left. 1, 2, 3, 4, 5, 6. So h is going to be -6. And you can see that this has been moved up 2 units. So k is 2. And from that, you can just drop that into the equation, the general form of the equation. So it's y equals a, like I said, is always going to be 1 when we give you a problem like this. X minus a -6. It's going to be +6. And then plus k, so +2. And there's the equation. All right, so this section, obviously, a lot of graphing, a lot of analyzing domain and range, and then this sort of small wrinkle at the end where you take a graph and then you try to work back to the equation. But that pretty much wraps up section 4.